All right. Reduce or fold, same thing, but I think fold is easier to understand. I'll kind of show a cool visual representation of it. So I made this. So this is an array with just four elements, right? An array of integers, numbers, and the numbers that I arbitrarily chose for this example are 1, 3, 5, and 7, right? So position 0, position 1, position 2, position 3. Cool. So we want to reduce this thing, and let's say like that the operation that we're doing within our reduce function is to add the elements together. So basically the thing that we want to do is create like a full sum of this array. What we would do is we would first like quite literally fold the first two elements together. So you're considering these elements one at a time. So we would fold it like this, like one way to figure out the sum, right? Without just like adding up all these numbers in your head is going to be to fold over like this and basically add these first two elements together. Do that reduce whatever operation we're doing on these first two elements, adding them together, which is going to be 1 plus 3 is 4. Fold that over, and then I'll write 4 on this one. So this is also called, in reduce, this is called the accumulator. But now this is what our kind of like new temporary array, working array looks like, right? So we basically have like the folded or accumulated value 4, and then the remaining values to consider. So now the next step is we take the next step through the array. We grid the next value, which is 5, and our accumulated value, which is 4. We're going to combine those, right? We add them together to get 9, and then we fold that over again. And 9 is that new folded value. So now we have this big, you can kind of see how I have the paper maybe, like there's this big folded value for 9, and then that final remaining value that we never touched yet, 7. And then again, we just run that final operation, fold over like this, fold to the right, and now this is going to be 16, right? 9 plus 7. And basically this is our final output. We're back, we've reduced it to a single element, and the answer is 16. So you could do all kinds of operations. Let me see, if I did this in a sane way, I didn't quite. Well, here, I can show an operation. You can fold left, right? Fold left is kind of the other way to do this. So we did a fold right, or like a reduce. And basically the reason it's called a fold right is that we start with the first element and we fold like literally to the right. We could also start, if we want to fold left, we can start from the end and then fold to the left. So we can start 7 plus 5. So basically we start from 7, and now the next value that we're considering is 5. We're adding them together to get to 12, and then we fold that to the left, like so. Boom. And then we'll put 12 here on this value. So from here, we could fold left that 12 with the 3 for our next value to get 15, and then we do a final fold, again, 15 plus 1 to get that 16. So here the operation that I chose to implement was just like addition. It could be all kinds of things. You could like concatenate strings. In this case, just like it doesn't matter for fold. Obviously, we would end up with 16 whether we went folded right or folded left. So it doesn't really matter. But for some operations that are ordered, like concatenation, maybe it would matter. Anyway, yeah, let me know if that helps at all.